Okay, so in the previous class we've done 3 and 4 questions on page 134, 35. Now 5 and 6 on page 136 textbook. So let's go to question 5, textbook, page 136. Go there. Let me read the question for us. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance. So rolls down from rest. Since truck starts from rest, you can use the starts from rest. So the key word here is rest, means the initial velocity is 0 meter per second. At the beginning it was at rest, means not moving, with a constant acceleration. So continue, it travels a distance of, it, second sentence, travels a distance of 400 meter in 20 seconds. So these two here will give you the information. Meter is obviously distance, S, we know that, right? In motion chapter, we're usually denoting the distance by S. Then second is obviously very easy, time, so 20 second, everything is in SI unit. Find the force, last sentence, so force F, question mark. Then acting on the rolling truck, okay, to make it roll. If its mass is 7 tons, so mass of the truck is 7 tons, but tons is not SI unit. In the bracket, since it is given 1 ton is equal to 1000 kg. So 7 ton will be 7000 kg is the mass of the truck. With this, we have to find the force, this one, and before that also one thing is the travels, find its acceleration also. So A also, A equal to question mark, the acceleration by which it is falling down, the increase in velocity. So we will start now. Here U, S, T, A is involved. So U, S, T, A. Remember, since in the famous equation of motion in chapter 8, S is equal to UT plus half AT square. I think we can use this because S is there, U is there, T is there. So we can use this to find A. So let us just take the term containing half AT square equal to, and then S, you shift this one this side, become minus UT. Okay, to make it easier, now here that will be equal to A, you keep it, don't move this, then shift this one and this one, then it will become S minus UT divided by this T square will come down, because if you shift up will come down and down will go up, so into here 2 at the back, or here it will go, so 2 will go up, T square will come down. So we got this situation. Now here that implies, now you can just take this A equal to, because they're asking us to find acceleration, so with this formula we can find A, because S, U, T is there. See, S, U and time is given, so we get here 2 into S is 400 meter minus UT, U is 0 meter per second into T is 20 seconds. So S minus U T divided by T square. So T is 20 into 20. T square means second square. So we got that. Now it's a matter of patiently doing it. Now this is into, so we can cancel this if you want. 2 tens are 20. Okay, then here 400 meter minus 0 into this means 0. So you can just neglect that one and just write down. Minus 0 means no need to write also, by 10 into 20 second square. Then here 1 2 1 2 2 2, so this is going to be 2 meter, and if you shift this second to the power plus 2, the power plus 2 to the numerator, then it becomes second to the power minus 2. So we can just keep this one as equation 1. They also told you to find the force with which it is rolling down. So since formula by second law of equation is F is equal to mass into acceleration, mass of the vehicle is 7,000 kg into acceleration just now 2 meter per second square. So we can write here, since we know M is given as 7,000 kg, and then using equation number 1, right? Then as we continue doing this, we're going to get here next equal to 7 2s are 14,000 triple kg meter per second square. Kg meter per second square. So we know this is the best unit of force. Kg meter can be written in short as Newton. So this is equation number 2. So we found the answer. So let us start with the first one. Since we've calculated A to be equal to 2 meter per second square by, you can say by using, we know this by using equation number 1 here, which is positive. Positive acceleration means this rolling speed is increasing. Negative means it's the picture of a car applying brake and car slowing down, which is positive. Therefore, acceleration is 2 meter per second square in the direction. If it is minus, opposite, but in the direction of rolling of the rolling down truck. First answer. Then since F is also plus 14,000 Newton, as you get this one by using equation number 2, which is clearly now positive. Therefore, what is the force of friction between the, find a force acting on the vehicle. So force acting on the falling vehicle, that means, is 14,000 Newton in positive, therefore in the same direction, that means in the direction of rolling. If it was negative, then it would have been minus. In the force would be acting in the direction opposite to the rolling of the truck. So that's the first answer. Okay, 5. One more question before we end this test portion. 6. Last class we did this. This class we're doing this too. Sorry, 5 and 6. So let's go too slowly. It's not hard, but it needs some attention and carefully calculating. That's all. So let me read the question for us. 6. This is on page 136. 6. A stone of 1 kg is thrown with a velocity of 20 meter per second. Okay, just write down if you want. This is also one way of doing it. Since a stone of 1 kg is thrown with a velocity of 20 meter per second across a frozen lake, means a lake just turned into ice and comes to rest. These are keywords, okay? Rest. This one. With these things we're going to solve. That's why I'm just marking it. You don't need to mark. Traveling a distance of 50 meter. after it comes to rest, that means after traveling a distance of 50 meters. So here, these are the key information. So here, clearly we know kg means mass. 1 kg is the mass of that stone. And with a velocity means that this first velocity, initial velocity u equal to 20 meters per second. And comes to rest means finally it comes to stoppage. So final velocity v will be 0. Then traveling a distance means after covering s equal to 50 meters. That's enough. Now, last sentence. What is the force of friction? So F equal to question mark. Force of friction between the frozen lake and the stone, that means. Because of the friction of the ice lake on the spot, it finally came to rest. No? So friction force between, yeah, this is all you have to find. So now here, you know that to find F, you need M and A. We don't know A yet. So how do you get A? Because M, U, V, S is there. Now you will remember that in the chapter for motion, twice AS is equal to V square minus U square. Why are you using this? Because here, we are given here S. V is there, U is there. So with this help, we can find A. Once you get A, you can multiply that A with the M that is already there. So here now, that gives you, we're trying to find A, so A equal to V square minus U square divided by 2S will come down. So that we can put this value of A here to find the friction force. Okay, so that will give you equal to V square minus U square means 0 meter per second whole square minus U square, here U is 20 meter per second, the whole thing square. So square separate, you see, divided by 2s. So 2 into s is 50. So we write here 50 meter. 0 can be neglected and minus here. Then 20 into 20 is 400. And meter to the power 2 is meter square. Second to the power minus 1. So 1 into 2 is minus into plus minus. You have to multiply the power. So 1 2s are. So this would become minus 2 power. Divided by, okay, 2 into 50 if you like, 100 meter. So this meter, 1 power, then 2 minus 1, 1 left, 2, 0. So I'm getting minus 4 meter per second square. So this is A, equation 1, let us say. Therefore, friction force can be now calculated, M into A. So that will be equal to M is 1 kg. The stone is of 1 kg mass, as you can see here. Into here, just now acceleration is minus 4 meter per second square. And you can write here since using equation number 1. And plus and minus is minus. 1 4s are 4 kg here, and then this 1 meter per second square. And we know that kg meter per second square is the best unit of force, which can be changed to Newton. So we write here, which is negative, that means minus. Therefore, here, force of friction between stone and ice. So force of friction here between stone and ice is minus 4 Newton, like this also you can write. If you don't want to write minus also, in the last step it's okay. Till the last second step, the sign has to be correct, 4 Newton. Because you're going to mention here, you don't need to write. If you write also okay, in the direction opposite to the stone. Like that also you can do without mentioning, or you can start like this. Let the stone be moving from left to right across the lake. say. Not necessary, as I said, but if you do that, then advantages you can clearly mention here, that is from right, that is from right to left, that is from, okay, you can mention here, that is from right to left. That is the advantage, becomes clear in the picture of our mind. That's why, otherwise without writing this also, this is enough. Okay, from right to left, the stone is moving from left to right because it's minus force, friction force of the ice on the stone. Therefore the friction force of the ice acting on the stone to make it stop is from right to left, opposite. So this concludes the part for this test. You can give the test. I hope it's clear. Okay.